Hello and welcome again to my channel. Today in this video we'll be solving another LeetCode question, which is recover binary search tree LeetCode number 99, and it is marked medium. You are given the root of a binary search tree where the values of exactly two nodes of the tree were swapped by mistake. Recover the tree without changing its structure. So what we need to do in the question is we'll be given a binary search tree which will be wrong, right? Because it is said that exactly two nodes will be swapped. So it won't be a correct structure of the binary tree. So we need to recover the correct version of the binary tree without changing the structure. Basically, we just need to swap the mistake, the nodes that were swapped mistakenly. We have to reswap them, right? So let's understand it better. Mm, this is the first example, this one. So those of you don't know what is a binary search tree basically says that for every node, the left child will be smaller than the current node and the right child will be bigger or larger, right? But if you see this one, if you see this binary search tree BST, you'll find that the left child of 1 is 3, which is not smaller. That means this binary search tree is wrong, right? And we need to fix it. How do we fix it? By doing this. Yeah, we exchange the values of these two nodes. Now if you see, the left child of 3 is 1, which is correct, it is smaller. The right child of 1 is 2, which is larger than 1, so that is also correct, right? So we have recovered the original binary search tree. In the second question also, if you'll see, the left child of 3 is 1, which is correct. The right child of 4, the right child of 3 is 4, which is larger, that is also correct. The left child of 4 is 2, that is correct. So it might seem that the whole binary search tree is correct, but if you look closely, this 2 is on the right side of 3. The right child of 3 is 4, the left child of 4 is 2, that is also correct. But as a whole, the 2 exists on the right side of 3, which it should not, right? Because 2 is smaller than 3 and it should appear on the left side, right? So if we swap these two nodes and we get this. Now if you look, it also follows the rules. The left child of 2 is 1, which is smaller. The right child of 2 is 4, which is larger. And the left child of 4 is 3, which is smaller. Now 3 is a left child of 2, sorry, right child of 2, and 3 is larger than 2, so that also follows the rules of BST. So in this case we swapped these two nodes, right? Now how will we solve the question? How will we approach it? We'll do an in order traversal. What is that? We'll basically try to find the ascending order of the node values, right? So the node values here are 1, 2 and 3, and the ascending value will be 1, 2 and 3, right? This is the correct order of node values in ascending order. But if we do an in order traversal, again, those of you who don't know, an in order traversal is basically going to the left first, then current node, and then to the right side of the node, right? So it's basically this. We'll traverse the left first, then to center node, then to the right child, right? So if we do a in order traversal in a BST, we'll first encounter a left child, then the current, and then the right child, and in that order we'll always get an ascending um, list of numbers, right? Why? Because it is said in the BST rule that the left child will be smaller than the current child, that is the center child, and the right child will be larger. So left will be the smallest, then the center, then the right. So if we do a traversal of this kind, we should get an ascending list of numbers. So let's try doing this in this one, what we get. So we'll start from this one, but we'll not take this into account. We'll first travel to the leftmost child, right? So that means we go from here to here. Then we again try to travel the left side, but here we do not have a node. So the leftmost child is this node, which is 3. So in our list, the first number that will appear will be 3. Then we travel back from here to this, right? So it appears. Now we have traveled left, we have traveled back to center, and now it's time for the to travel to right, right? So we travel here, correct? So the current node is 2. We travel left, nothing. We travel back again here, so 2. So here the 2 will appear now, and then we try to travel right, nothing. We go back, and we return here. And when we return here, this 1 will appear here. So as you can see, this is not an ascending order, right? This is not an ascending order. And okay, so we have done the traversal, we have found the list, right? Now we need to fix the list, and that will give us the answer. That will be the solution, right? We need to fix the list. How will we fix the list? The actual list is supposed to be 1, 2, 3. As I said, the actual list is supposed to be 1, 2, and 3. That means if we replace again 1 with 3 and 3 with 1, that will give us 1, 2, and 3. 2 is in the correct position. We need to replace 1 and 3 with each other, right? Now how will we know that we have to replace that, right? So for that, we'll take 3 variables, right? We'll take 3 variables called first, second, and previous. Okay, so the first and second are pretty obvious. Why we have taken first and second? Because in the question itself it is stated that only 2 nodes will be swapped, right? So we need to look out for only first and second node, basically, right? And previous will help us in having a previous will help us in keeping track of the last visited node. And why do we need that? Because we need to have the last visited node to ensure that we are following the ascending order. Let's say we are here and the next node we encounter is 2, and we have already stored 1 in the previous node, right? So we can check if the value of the previous node is smaller than the value of the current node, because that should be the order, right? In ascending order, the previous node should be smaller than the current node. If it is, we are good. If it is not, we have found our wrong nodes, right? So we'll start from here, right? We'll say, okay, this is the 3, there is no previous. Okay, so we'll make this the previous node and we'll move on, right? Now when this is the previous node and we are here, we'll find the faulty node. Why? Because we'll check if previous node is smaller than the current node, and it is not. 3 is not smaller than 2. That means we have found our first culprit. Have we not? We have found, which is this 3, right? And we'll store that in the first value. So that means the first will become 3 and the second will become 2 for now. Okay, we'll go into the logic of the code and it will become clearer, but for now second will be 2. Then we move on, and when we move on, we again save this as previous and we are here, and we check again if the value of previous node is smaller than the current node. It is not. we again find the fault here. Now, since we have already filled up the first position with 3, we'll change the second position with this value, right? And this will instead become 1. And that's how we have found the two nodes that we can swap. We needed to swap 3 and 1, right? And we have found that. And we'll swap them and it will become this tree. If we do a traversal of this tree, we'll find that we'll get the 1 2 3 as an answer. Okay, so we'll travel to the leftmost child, nothing here, so 1 will come first, then we travel right, we get 2 1 2, and we travel all the way back, and lastly we get 3. So the ascending order would be correct. So that's the solution for this question. Let's try to code it, and we'll dry run this second example after we have implemented the code. That will better help you understand the code as well, right? So the first thing first, as I said, we'll take 3 variables, first, second, and prev, right? So first, second, and previous of type t node, because we'll be storing each node in them, right? And previous will take a value for that initially, will be we'll take something very small so we can store previous value, right? We can compare them, right? Now we'll do the in order traversal. So var in order func now the first step, as always, will be if the current node is nil, we'll just return, right? That's what we did here also, right? If it was nil, we did not do anything, we just returned back, right? So if node is nil, we return, else we travel left, right? Whenever we have a node, we always travel to the left side, right? We always travel to the left side. So we'll do recursion function and we'll travel to the left node of the current node, right? Now after we have traveled all the way to the left, that means we have covered the whole left subtree, we'll come out of this here, and then we'll check, right? We did the check, right? That after traveling a node, we checked if previous value was smaller than the current value, right? So we'll do that. If first is equal to nil, that means we have not set the value of first yet, and previous value is larger than current node value, which it should not be, right? Previous value should be smaller, right? So that means we have found a first faulty node. That means first will become the previous. That's what happened right here. We set first to be third, which in that case was the previous node out of these two. We are comparing 3 and 2. So 3 was the previous node and 2 was the current node, and we set the first to be the previous node, right? That's why first equal to previous. And then we'll also check if first is not equal to nil. That means first has already been set, and now we want to set the second variable node, right? We want to set the second node, and same condition, previous val is larger than node dot val. That would give us second equal to node, not the previous one. Why? Because again the second was set to 1 and we were comparing 2 and 1. Here 2 was the previous value and 1 was the current value, current node value, and we set the second value to be the current node value, not the previous value, because the faulty one's 3 and 1, not 3 and 2, right? That's why the second will be set to node. We'll come to this again when we do the dry run of the second example, right? and it will be much clearer there. Then after we have processed the current node, we'll move on to the right side of the tree, because that's what we do. We move to left, we process the center, and we move to the right side, right? Before that, we'll set the previous to be the current node, right? Before moving forward, we have to set the current node to be the previous node, because this will become the previous node, right? And then we do in order node dot right. Now we have to call the function as well. So in order of root, because we have the root initially, right? Then now when the DFS function ran, all it did was set the values of first and second and previous, obviously, but we only need the first and second, right? And once the values of first and second are set, we need to swap it after it has been set, right? We need to swap it. So first dot val comma second dot val equal to second dot val comma first dot val. That means we are setting the first value to be the second's value and second dot val to be the first value. Let's run this and see if there's any mistake or not. Okay, and it is working. Now with this code in mind, let's do the dry run of the second example as well. Okay, so the first thing we do is traversal, right? So let's travel here. So we'll travel from here to here, right? And here to here, and we move back because there is nothing, and we come back here. We come back here, right? So the first node we encounter, that means we'll set the value as 1. Then again the same thing, we move right, we found nothing, we go back, so we'll set the second value to be 3. We move to the right side, then for this node we move left, nothing, we return, we get 2, so we'll set the value 2 now. Then we move right, nothing, go back, we reach 4, so the value will be 4 here. We'll move again, but we'll find nothing, we'll go back, we'll exit, right? So that is a traversal. Now so we find it to be 1 3 2 4, and it is obviously not ascending order, right? We need 1 2 3 4, 1 2 3 and 4. So that means the ones we need to replace are these two, right? We need to replace these two. So what happens? Let's see. As we are traversing, we'll first encounter 1, right? And there is no previous, so 1 itself will become the previous value. Let's do that. We'll keep track of everything now. Previous will become 1, right? Then first is still nil and second is also nil, right? We'll keep track of these things. Okay, so now when we traverse, previous is 1, okay, we are done with this. We move forward and we reach here. We are currently in this node, right? So for this node, the previous node is 1, and we check if previous node is larger than the current node. It is not, so it is correct. That means previous node is smaller than the current node, so this is correct, right? So now we again move forward and we reach here. So then previous becomes 3, right? We have not yet set first or second, and previous becomes 3. Now we check again, that is previous larger than the current node, and it is, which it should not be, right? So this is the faulty node. So the first will be set to 3. First becomes 3 now. Now we if we see the code, this ran, right? We found that first was nil, correct, true. Previous value was larger than the current value, true. So we ran this part of the code and first became previous, which in this case was 3, right? 3 was the previous, so first becomes the previous. Now we'll reach this part of the code. Now since first is already set, first is set, right? First is not nil, that is a true condition, and previous value is greater than the larger node value, that is also true condition. So that means this code will also run, and second will become the current node. Second will become the current node, which in this case is this one. So that means second will become 2, right? And then we move on, okay? And when we move on, we reach this current node, and this is the previous node now. So we check again if previous value is larger than the current value. No, 2 is not larger than 4, so it is following the ascending order rule, so that is correct. And we do not run this code again. That means we have found the faulty nodes, 3 and 2, 3 and 2, and we swap them, which is what we did, right? 3 and 2, 2 and 3, correct. Now let's see what happens here, how it helps, how that code helps us here. Okay, so again, here let's keep track of everything again. The previous will begin with 3, the first value, then first will be nil, and then second will also be nil, right? Okay, so we start, we are here, we are done with this. Previous becomes 3, current node is 2 and previous is 3. Previous is larger than 2, this is not ascending, so that means we'll run all this, right? First is nil, previous is larger, that means first becomes previous, so first becomes previous, which is 3, and then we'll run this code again. Now first is not nil and previous is larger, then second will become the current node, so second becomes the current node, which is 2. But this is not the answer we want, is it? We are not trying to swap 3 and 2, we are trying to swap 3 and 1. So we move forward, we reach here, and this becomes the previous node. Here also the rule is not being followed, the previous is larger than 1, it is not in ascending order. So we'll run the code again. Here we will not run this part of the code because we have stored the value of the first to be this one. This is the first faulty node, so we'll not run this. Why? Because first is equal to nil, this condition will return false. Now first is already set, so this will not run, but this will run again. First is not nil, which is true, first is still 3, previous value is larger than current node, so the second node will become the current node. That means second node will become the current node, which is 1 in this case. So second will become 1, and that's how we find the faulty node in this case, right? Why this works? Because if you think logically, the question states, and this is the most important part of the whole video, if you understand this, you'll understand the whole video. The question states that there can be only 2 faulty nodes, 2 nodes that are swapped, right? And if you look at the diagrams, you'll find that if 2 nodes are swapped, there can only be 2 scenarios, which is the 2 nodes are together adjacent to each other, or they are separate, right? So we need to look out for both the conditions, and that's why this code helps us. We will set the first node only one time, we will not change it again. The moment we find the faulty node, it will be the first node, but the second node can be adjacent to it, right? Can be adjacent to it, or it can be farther down the tree. So that's why we'll set the second node multiple times, or in this case only 2 times, right? And we'll find the answer that way. So keep that in mind, that is the most important point, that there can be 2 scenarios, the two swapped nodes can be adjacent to each other like this, or can be far apart from each other. So that was all for today. That was the video. Like if you understood something, and I'll see you in the next one.